Yes, thank you everyone for coming. Today I'm going to talk about Cappulada, our ADA binding generator for C++ code. So what is our objective? We want to use ADA components in C++ environments, or maybe use C++ libraries with ADA. And while writing a binding is technically relatively easy, if you have a large API, it's quite cumbersome and you need to do a lot of stuff manually that could be automated. And there are already existing solutions. So the GCC provides a binding generator. GTK ADA uses a binding generator for their GTK code. And also there's a project on GitHub called Headmaster, which generates binding for C code. So why do we want to reinvent the wheel? Well, all of these solutions have drawbacks that we need to overcome. So the GCC binding generator generates uncompilable code, which is quite bad because you would have to build a post processor anyway that fixes the errors the GCC makes. Also, they don't support things like templates, and some symbols just are left out because GCC says, well, this isn't a valid ADA symbol. And if we wanted to fix GCC itself, we would probably have to maintain our own fork of GCC, which isn't really feasible in the long run. Also, GTK ADA, this is really project specific, and they just generate GTK bindings from GTK's own specifications. And also they have no C++ support. The same goes for Headmaster, which is really an only C project. So what do we want to do? Well, we want to automatically generate ADA bindings from C++ headers. We want an API layout that keeps the types and that which has a semantic mapping. So if I have a namespace and a class called A and B and maybe a subclass called C, if you use that in ADA, this should also be A.B.C and not any further packaging around it, but we really want to use the binding as native as possible. Also, we need to automatically generate all the import linker symbols. And we have to detect name collisions, because if I have a variable that is called begin in C++, this won't probably work in ADA because it's a keyword. So we have to get that out of the code or rename it in a valid way. And also, since we are often using with Spark, the generated bindings should be as Spark compatible as possible. So if we use function pointers in C++, we won't get Spark code. But for a normal class that doesn't use these things, Spark is possible. So what are the C++ features that are hard? Object orientation. Okay, we have that in ADA. But we want static and dynamic dispatching to work, so we have to look in C++ if we have a vtable and if we use virtual functions, and if we need to use a tag type in ADA. Also, we want to use C++ templates, which is a concept that doesn't exist in ADA. So this is going to be interesting. Also, variadic templates, which means we have a C++ template that has an yet unknown amount of arguments, and you can instantiate it with just as many arguments as you want to. And we want to automatically call constructors and destructors. So if you have a record in ADA, you can just take it and it's there. But in C++, the class needs to be constructed by the constructor. And also, if it goes out of scope, it needs to be destructed. And if it goes out of scope in ADA, this doesn't happen, so we have to fix this somehow. This is our architecture. So the upper layer is the data and the lower layer are our components. We have the C++ headers and just pass them with libclang because it's easy. That gives us an abstract syntax tree. So basically the C++ code as a tree-like structure in memory. We have a converter where we enrich this data. So we have to instantiate the C++ templates by our own, because the instances are not in this tree. And if we find a template and we find a template use, we have to create an instance of this template that binds to the actual instance that is generated by the GCC when compiling the C++ code. With our intermediate representation, where all this data is existing, we can then call a generator that takes the data and just generates ADA snippets, and those snippets are then put together to a complete ADA specification. So how does this look? We have a small class, the namespace and a class, and we have a public member and just the constructor. And the generated code is a package A that represents the namespace, and a package B that represents the class. And since we don't want to have state in our classes, but we want to have objects, the class object itself is a limited record, which then contains the member variable, and the constructor is an auto-generated function that returns this type. And the pragma C++ constructor is from CNUT, which tells CNUT, okay, this is our constructor, and we have, and here we have to supply the constructor symbol of the object file. And then if we call this function, the C++ constructor gets called and returns us an initialized object. How do we fix the naming problems I told further? So at first we apply ADA casing. This means, I don't know if this is in the standard, but it's good practice. So uppercase at each beginning word and delimited by underscores. Also, if you have invalid things like leading underscores or double underscores, we just insert an X. And also keywords are prepended with an X. If we have unmappable characters like this German umlaut, we replace it with the UTF-8 sequence and hope that nobody else in the C++ code ever did use this variable name. Yeah, so that's like a little more advanced thing. We have a C++ template. So C++, I hope everyone knows what C++ templates are and how they work a little bit. So they are basically just code that isn't in an object file, but once you instantiate it, this code gets copied with integer as type, and then if you instantiate it again, it gets again copied, and those are two different things then. And for Ada, we have to somehow map this. Since we don't have templates, we just use some name mangling. So the class A gets A, and then underscore T for template, and then underscore int for the integer here. And the other thing is a package A underscore T and underscore T for B for the instance of B. And then we have two separate things which we can use from Ada. And if we call something from this package, actually this instantiation of the template will be used. So what are the challenges? Well, the name escaping, as I said, you can just push all the names into C++ and hope that it collides somewhere after our name mangling. So because the C++ identifiers have a complete superset of the Ada identifier rules, so you can just do anything that isn't allowed in Ada. Also real C++ generics. So the problem is C++ generics, aka templates, are a compile time construct, while Ada generics are a runtime construct. So if you wanted to use templates as you use them in C++, you would have to add some preprocessor to Ada that does that. But I also use Ada because it doesn't have a preprocessor. And using Ada generics to do things that are usually done at compile time isn't really working. So you can't use Ada generics to map to templates. And we have circular dependencies in C++ code. So you can generate a forward declaration, use it, and then declare something else. I have an example for this. So you have a forward declaration class X. This just tells, okay, we have a class X that is something. And then we have a class Y that uses a reference to this class X. And then we have the class X defined that again uses the class Y. So we have a circular dependencies because these both classes depend on each other. In this case, we only have a reference, so we can fix this by a so-called limited width. Those are two files, so think a line here, which divides those files. And when we, in this limited width, gives us an ADA the possibility to do some kind of circular dependencies. So we can define an access type of x.class, which is defined in the X package. But we can only define an access type, so we can't use x.class directly. But we have our reference that is used here. And then we can just with y in the X package and use it regularly as an object. So the conclusion of this, we can map complex C++ scenarios in Ada. Also, advanced features such as templates can be used to some extent. We think that this is sufficient for a real-world use in the most cases, but some features are just not doable or really hard to do. So yeah, it's still under heavy development. There are quite some bugs we need to do, and we don't, for instance, we currently don't have array support, so this is some quite important feature that we need to add. But we support namespaces, classes, and templates, type defs. And you can find the project on GitHub if you want to help us in doing all these other hard things. And now I have a small demo for you. Mouse. Yeah, you can see this. So we have a simple C++ library called number that just is a template of the class number, and it has a value. Is this large enough, or should I maybe make it a bit larger? So, and you have a function add that adds something to the value, and a function value that returns the value. And now we want to use this in Ada. So since this is a dummy library and there's no and there's only this header file, we need to trick the GCC to instantiate our template because we need the compiled code at the end to link against Ada. So this is a dummy class that just tricks GCC into actually creating an object with all these functions that contains all these functions. Otherwise, they would just be not existent. Yeah, and we need to create an object, so we have to instantiate this once in a CC file, so we get something to link against. This is something you probably don't need if you use a real world library. And yeah, let's create our example. So we call it on number and we name it example, which is just the top level package name it gets. And now we have our example.ads that uses interfaces.c for obvious reasons. It uses Spark, and we have some type renames and more type renames. And there's our package number, which is a template instance of int. We have our private value here. This this happens because we don't want to alter values in Ada that are private in C++. So we want to somehow keep this mapping, but we still need to have this value in the record. Otherwise, the C++. Can you see the cursor? Yes. Otherwise, the GCC will create a wrong memory layout, so we have to keep this. And we have the constructor with a symbol, and we have an add function with a symbol. Let's scroll a little bit. And we have the add function and the value function, and there's our dummy class starting, but this isn't really interesting. So, and now we have our example program. So this is just boilerplate code that reads command line arguments. And here we use it. So we say, okay, A is an example number GInt class, and it is created by the constructor with the value of x. And then we add the second argument, dy, to this object, and then we just return its value. So, and here we put out the value. And if I compile this, I get a little program called add, which will just add two numbers, and like 5 and 4, and we get 9. So yeah, that's it. So thank you. I'm finished. Are there questions?
Yeah, well, one technical, maybe two. So I'll start with perhaps more straightforward one. So you are mapping, I noticed you are mapping C classes into packages, not like, because you could technically try to go with type and then just make a mapping like that. Is that because class in C++ also provides a namespace and you want to have this?
Yes.
Because otherwise you could have different mapping.
Yes,
Okay,
because
so
the add function, for example, in C++, you call this add function with class name or with object name dot add.
Yeah.
And
so you want to keep that mapping.
yeah,
Okay, yeah.
because if you don't do that, and you have two classes that implement add, you would collide in Ada if you don't encapsulate this.
Okay,
Yeah.
I see that, because in principle it's solvable, but that I agree.
Yeah.
That's automatically you get name result.
Yeah.
The generics, I mean, templates and generics are not the same, sure, but wouldn't it be, I mean, you can, as far as I can see, implementing templates as generics, as like generic package, could be actually even simpler. Going the other way around would be way more complex.
Well,
But
the problem is templates are compile time and Ada generics are runtime.
still you can emulate
Yeah.
behavior.
I thought about the thing.
Because it kind of logically, I expected your like two pieces of code, like template, that you would make like generic package and then instantiation of this package with this specific type, because that's like the main use, the intended use on the other side and the intended use on the C side. It's true that like then people abuse this stuff, like horribly abuse it, especially in ADA, like to make like proper multiple inheritance. In ADA, they use generics. That's not what they were designed for, I do understand. Yeah. But still, that seems to me kind of the natural mapping.
Yeah, that's true. But due to the technical differences, it's really hard to map that correctly, because you have to move something that is usually happening in runtime to the compile time, and then you lose the possibility to make, for example, to instantiate Ada generics with runtime variables. That is not going to work with C++ templates at all.
Yeah, but you are generating other code for C. I agree that if you were your task.
No, we are only generating the bindings.
Yeah, the bindings. That's what I mean. If your task was the opposite, that would be a severe limitation. You cannot, with C++ templates, really completely emulate other generics. But it seems to me that other generics should be able to give you most of the templates of C++.
Can we talk after?
Okay, yeah.
Yeah. So the, you had.
What's the most complex or the most popular C++ project that you want to run?
We are building this to use Ada in the Gnode OS framework, which is an operating system framework built on C++ and uses all the extensive templating and stuff. So yeah, I would say this is quite complex. The Gnode guys are sitting behind there, so you can ask them about the Gnode project. Yeah, I would say this is the most complex thing we are currently doing. It's not working completely, but some things are already mappable. You had a...
It was a similar question.
Okay.
I was asking if you were planning to apply it for, I don't know, Qt or big
Qt is something else, because they have their own preprocessor stuff. And yeah.
I noted that when you map a C++ class into an Ada type, your type is limited, but it's not that. customize that it doesn't have a dispatch table. It can be running with dispatch.
The point is, in
I
C,
understand that this class doesn't have any descendants that are visible. Maybe the compiler generates tagless type at the object level.
the problem is in C++, if you create just a class, as you have seen here, it doesn't have a v-table, which means the memory mapping starts at 0. And if you add a tag, the memory mapping starts at byte 8. And the same is the other way around. If you use a v-table, for example, due to a virtual function, the memory mapping in C++ starts at byte 8, which means that C++ classes that use virtual functions are tagged classes in Ada, and those that are not using virtual functions or are not derived from virtual functions are not using tagged types in Ada.
Well, generate can detect that
Yes.
that has a virtual function.
Yes. Yes.
Small detail, why didn't you use the interfaces.c package? It seems you map int to integer, while in Ada you have a package especially intended for that mapping called interfaces.c.
We use the interfaces.c for the types. We just rename.
In the example, the int was mapped to Ada's integer, not to Ada's interfaces.c.int.
Here it is mapped. We convert it to our example.int, which
Oh yes, okay.
which is a subtype of interfaces.c. The point that we rename all these types because we want to keep our own namespace. If you convert, if you generate bindings for a project, everything that comes from here is its own namespace. So we rename it.
No, that's fine.
Yeah.
Can you call a C++ function that expects a struct, not just the pointer to a struct? Because I tried to do this before, and then I had to use libffi or something.
I've done an Ada function that returns a struct and got the struct in a C++ map binding, so the other way around, and this worked. I can't say why it shouldn't work. So yeah, in theory, you should just be able to put a struct in the function.
Did you add the pragma convention to the structure?
Yes.
Okay.
So if I go down here,
The order of components might
convention
be
C++,
different
yes.
plus in Ada.
Maybe you need to continue.
But if you put the
Very
pragma
small question.
conventions,
Okay.
We have to wrap.
then the
One
Ada
remark
record
maybe,
will
I
be
think,
generated like a C++
Ada is quite straight.
struct.
C++ is quite weird. Don't you fear that you import the weirdness of C++ into Ada?
To some extent, yes. On the other hand, I'm not able to rewrite everything that I use in C++ that is currently written C++ in Ada, so I'm probably better by importing some things and saving some time.
Okay.
Yeah.
Thank you.
Thank you.
Thank you.